We just got a huge update on 3I Atlas, the interstellar object that's been defying every rule of physics. It went behind the sun, came out brighter, bluer, and moving faster, showing clear signs of non-gravitational acceleration. NASA's data said it should have lost about 13% of its mass near perihelion. But now that it's back in view, there's no cometary tail at all. Harvard astrophysicist Avi Loeb says that if 3I Atlas really vented that much gas, we should see a massive cloud of dust, just like any normal comet. Comet Lemon, observed days earlier, shows that perfect streak away from the sun. 3I Atlas? Just a fuzzy ball of light. Even after enduring nearly 770 watts per square meter of solar heating, enough to vaporize carbon dioxide ice, it stayed compact, silent, and strangely intact. So what's going on? Loeb says maybe small ice fragments are burning up before they can form a visible plume, or maybe something else is happening. Since perihelion, 3I Atlas has grown 5 times brighter and developed a blue tint, color shifts we usually associate with high-energy reflection, not dusty gas. It's the kind of data that makes scientists uneasy, because it doesn't fit the model. The question now is simple: natural or technological? If it's natural, what kind of system creates something like this? And if it isn't, who sent it? It's turning blue, glowing hotter than the sun when it should be frozen solid. It's showing a non-gravitational push, as if something inside it is producing thrust. And while the sun hits it with nearly 30 billion watts of energy, it barely changes at all. Most comets crumble under that kind of heat. This one didn't. It just kept shining, a bright blue anomaly racing through the solar system. But surviving the sun was only the beginning. What the instruments saw next wasn't just beautiful, it was impossible. 3I Atlas, the third interstellar object ever detected, has now cleared perihelion, and instead of disintegrating, it's growing stranger by the day. It turned blue. NASA's solar monitors recorded a rapid surge in brightness, and then, almost impossibly, the object's color shifted, bluer than the sun itself. In astronomy, blue means hotter light, higher energy photons. Comets, on the other hand, are cold, dusty bodies that scatter sunlight and glow red. So for something frozen and distant to shine hotter than the sun, the gas around it must be incredibly hot. Reflected sunlight alone shouldn't be capable of that. Data from spaceborne satellites, Stereo, SOHO, and GOES-19 show its brightness rising far faster than any known comet, scaling with its distance from the sun to the power of -7.5. For comparison, most comets brighten to about -2 or -3. That means 3I Atlas brightened nearly 10 times faster than physics would predict. And as it neared perihelion, color photometry revealed something else. Its reflected spectrum was bluer than solar light itself, a temperature signature that shouldn't exist for a body nearly 20 times colder than the sun's 5,800 Kelvin surface. 3I Atlas should glow red, not blue. So what's lighting it up? One explanation is that jets of ionized carbon monoxide gas are producing the glow, a natural process, but one that would require intense heating. Another possibility, the one Avi Loeb and others have raised, is that the heat isn't just sunlight bouncing off ice. It's coming from within, as if the object were powered by an internal energy source, something capable of running hotter than the star that's illuminating it. Some call this the ninth anomaly. Whatever's lighting it up isn't behaving like reflected sunlight, and the brightness wasn't the only anomaly NASA noticed, because while 3I Atlas was glowing bluer than the sun, it was also starting to move in ways no comet should. NASA's navigation data shows something even stranger, a non-gravitational acceleration, a push without the usual signs of gas escaping. As 3I Atlas passed the sun on October 29, 2025, the numbers revealed 2 small but definite pushes, one directly away from the sun and another sideways along its orbit. The accelerations measured about 135 and 60 kilometers per day squared. For an object this massive, that means something significant is at work. If sunlight were driving it through normal outgassing, the math says it would have to lose nearly 10% of its total mass in a month, and about half within 6 months. But telescopes aren't seeing the ejected mass. There's no vast plume, no dust cloud, no debris trail that a venting comet should leave behind. 3I Atlas remains intact, moving as if something is pushing it, but without any sign of ice or vapor escaping into space. NASA's data confirm the acceleration, and that's the part that's hard to explain. Because if it isn't gas doing the work, then something else is. And that's where Harvard's Avi Loeb and his team start to wonder whether the thrust might actually be mechanical. a system inside the object itself, quietly producing the force we're seeing. The math doesn't lie. Something's pushing it, but it isn't gas. And yet, despite all that force, 3I Atlas remains intact. Which raises a new question. How much energy can this thing actually take before it breaks? At its closest point to the Sun, 3I Atlas is struck by about 770 watts of solar energy per square meter. Add that across its surface, and you get tens of billions of watts of power, roughly a third of all the energy produced by every nuclear plant in the United States combined. That much energy should tear a comet apart. Between July and October, scientists estimate it lost around 2 million tons of material, but that's less than a fraction of a percent of its total mass of 33 billion tons. So it's absorbing unbelievable amounts of heat and barely changing. That's not how fragile ice behaves. That's how structure behaves. Something dense, resilient, and built to last. Whether it's natural or artificial, we'll know soon. In December 2025, 3I Atlas will re-emerge from behind the Sun. On December 19th, it reaches its closest point to Earth, about 269 million kilometers away. For astronomers, that's the moment of truth. The Hubble and James Webb telescopes will both turn toward it, breaking its light into spectra to reveal what it's truly made of. If they detect water vapor and simple carbon molecules, it will confirm a natural comet. But if they find excess heat, metallic emission lines, or radiation that doesn't match sunlight, it could mean something else, something built. Avi Loeb calls this the acid test, the data that will decide whether 3I Atlas is a chunk of frozen debris or a functioning craft, powered from within. Perhaps it's ice, perhaps it's design, but the moment you see an object from another star accelerating on its own and shining hotter than the sun, you realize discovery isn't always rational. Sometimes it begins where reason ends, in the silence between what we see and what we're willing to believe. Thanks for watching. If this story stayed with you, leave a like. It helps the channel reach others who still wonder what might be moving out there. And if you want to follow what happens in December, subscribe and turn on notifications. We'll cover the new data as it comes in from Hubble, Webb, and beyond. Until then, keep looking up, because sometimes the next discovery is already on its way.